Okay, let's start the record. Okay, now we are back. So everyone give your role in the chat box. Everyone and give your role in the chat box. Okay, so I can figure it out that which students are present. Yes, everyone give your roles in the chat box, and for class continuation I am muting all my students. I'm muting all my student. Okay, I want noise free class, that's why I'm muting all. And we're just continuing the chapter. This chapter is very big. Okay, and we want to solve as much example as possible because there are several classes, so many classes, and the syllabus is also not very big like other courses. So we want to solve as much mathematical example as possible, definitely. So today will be the mathematical problem based on load curve. Okay, the load curve, we all know that load curve. What is load curve? Load curve is basically, sir, the demand of load during the whole day. The demand of load during the whole day we use. Okay, so if we see the first see the example properly, you see that a generating station has been given with the daily load curve. The daily load curve given here will be not given here. The value will be given. This value are given. We need to draw the load curve. Okay, this value will be given. Draw your load curve. Draw the load curve. We need to draw the load curve. Find the maximum demand. Units generates per day. That means total unit generated throughout the day in this power station, and the average load. What is the average load of that power station, and the load factor. What is the load factor of that power station? Okay, so let's first thing first. We need to draw the load curve. We need to draw the load curve. So as you can see that the given is 0 to 6. That means starting from night 0 to 6. Okay, night 12 is we are considering 0. 6 means 6 a.m. in the morning, and then 6 to 10, 10 to 12, 12 to 16, 16 to 20, and finally 20 to 24 at the night. So this is a 24-hour load consumption with the consumers. So at first we will draw the load curve. So we are, suppose, in the x-axis we are giving the clock. In the x-axis we are giving the clock, and in the y-axis we'll give the amount of power that is generated or uh, what can I say, either generated or uh, supplied. Okay, the supplied or used by the other consumers. So you see that at first 0 to 6, 0 to 6 means we will at first try to plot this load curve using that value. From 0 to 6 we have 40 megawatt. We have 40 megawatt. So from 0 to 6, from 0 to 6, okay, this is the x-axis value and this is the 40 megawatt. So this will be the point. This will be the point. So from 0 to 6, from 0 to 6, the load will be 40 megawatt. Okay, so it is done. Next is 6 to 10. 6 to 10, now the load is 50. So you can see that now load is 50 from here. So 6 to 10, this is 6 and this is 10. This is 6 and this is 10. So 6 to 10, the load is 50. Now we just join that, just like stairs. Next, 10 to 12, that is 60 megawatt. So this is 10, this is 12. So it is 60 megawatt. Now the 60 is in this region, so this will be 60. Okay, Now we'll just join with the previous one. So it looks like a stairs, 60 megawatt. Finally, uh, next 12 to 16, 12 to 16, it has 50 megawatt. One more time. So this is 12, this is 16, as you can see in the diagram. So this is 50. One more time and joining with the previous diagram. Okay, joining with the previous diagram. So in this way we will try to build the load curve. Okay, in this way we will try to build the load curve. So next will be 16 to 20, that means 70 megawatt. Okay, 16 to 20. 16 to 20 means it is international time. That means 16 you have to minus, subtract 12. That means 4 to 8. So 16 to 20, that is 70 megawatt. This is 70 here. So 70 to 60 to 16 to 20, the amount of load consumption will be 70 megawatt. Now joining with the previous diagram. And finally, we get that 20 to 24, that is 40 megawatt. 20 to 24, 40 megawatt. And joining with the previous diagram, we get the load curve. Okay, we get the load curve. So this is the load curve of the overall day, whole day, throughout the 24 hours of that particular station, of that particular power station. Everyone, please give your role in the chat box if you just joined, so you have the, just tracking that how many students have joined. Please give your role, everyone. Give your role in the chat box. So this is the load curve. So we have already drawn the load curve using that information. Okay, using that information, we have already drawn the load curve. But next will be, already 20 students have joined. Already 20 students have joined. Next will be, you see that we need to find out the maximum demand. The maximum demand of that power station. I have told several times that in the load curve, the peak value, in the load curve, the peak value will be the maximum demand of the power station. In this load curve, if you see properly, this 70 megawatt, this 70 megawatt is the peak, the highest value, the maximum value here. So that will be the maximum demand of that power station, the 70 megawatt. Okay, the 70 megawatt will be the highest value or the peak value or the maximum demand of that power station. Okay, so next will be the units generated per day. Units generated per day. If you see properly, this load curve gives us an area which is the units generated per day. Under this load curve, whatever the area, that means this area, this whole area under this load curve is the units generated per day. If you can calculate the area under this load curve, this area, okay, I cannot draw, but this overall area under this load curve, that will be the units generated per day. So we need to find out the area under this load curve. Okay, so how can we find out? You see that this is, we will divide into the rectangle. This is one rectangle. Okay, this is one rectangle. So we need to find out the area of this rectangle. We need to find out the area of this rectangle. You see that the one side is 40, 0 to 40, this is 40, and this is 0 to 6, this is 6. So basically 40 into 6, 40 into 6 will get the area of this area. Of this part we get the area. Next will be this. Next will be this area. Okay, this area I'm just drawing the second rectangle. Okay, this area. So this area, one side will be 50 and other side will be 4, 6 to 10, 4. So 50 into 4. Okay, 50 into 4. Next will be this small area. This small area. This small area. The one side will be 60 because the height is 60, and the other side will be 2 because 10 to 12, that means 2. So 60 into 2. These are the areas we are calculating areas. Okay, so because after the area we all sum, we'll get the total units generated per day. 60 into 2. Okay, so 60 into 2. Similarly, if we find this area, we will get 50 into 4. One more time, 50 into 4. 50 into 4. Next area, it will be 70 into 4. This area will be 70 into 4, and finally will be 40 into 4. So just the area calculation, just the rectangle, because we divide several rectangles, we'll get the area calculation. Finally, it will be 40 into 4. So there are, how many areas? There are 1, 2, 3, 4, 5, 6. 6 areas. If we calculate this area and sum all, we get the total area under the load curve. Okay. So let's go back to the second slide. So as you can see that the first thing, already I have already told that the maximum demand will be 70 megawatt maximum demand. The units generated per day, it will be the area under the load curve. So area under the load curve, you can see the 10 into 6, 15 into 4, 16 into 2, 15 into 4, 17 into 4, 40 into 4. I just showed that how to get this value. Okay, so if you calculate all, remember these all are megawatt. These all are megawatt. We see that the load is in the megawatt, 40 megawatt, 50 megawatt. So when units deal with kilowatt, okay, kilowatt hour. So kilowatt hour. So to convert the megawatt into kilowatt, we have to multiply with 10 to the power 3. So that's why finally, if we sum all, we'll get the 12 into 10 to the power 5 kilowatt. So this is the units generated full day. In the 24 hours, we get the units generated. Okay, 24 hours, we get this value. Next, we got maximum demand. We get energy units generated per day. Third will be the average load. The average load. You see, the average load, we all know that if we calculate the whole units generated per day and divide with the amount of hour of the whole day. So the amount of hour is 24 amount of hour. So if we subtract this total units generated per day divided by 24, we will get the units generated per hour. So that is the average load. Okay, so divide this units generated, that means it is total 24 hours generation. So if we divide by 24, we'll get the average 1 hour. That 1 hour data is the average load, that is 50,000 kilowatt. Okay, that is 50,000 kilowatt. So we got the average load also. Finally, last but not the least, the load factor. We all know that the load factor is average load by maximum demand. Average load by maximum demand. As I already told, that average load will be always less than maximum demand, always less than. So that's why the load factor is always less than 1. You see that 50,000 kilowatt, if we convert it megawatt, it will be 50 megawatt. It will be 50 megawatt. And maximum demand, it is 70 megawatt. So you can always say that the average load is always less than maximum demand. So 50 megawatt divided by 70 megawatt, if we divide this value, we get the load factor probably 0.714. That means 71.4%. 71.4% is our load factor. So that's how we need to solve this kind of load curve example problem. So I'm cleaning all and moving to the next example. I think you understand, because this is not a very tough. this is a little bit critical, not critical. The table we need to find out is E1. So you see that the value are given, the table we need to build, this table we need to build, it is not, it will be not given in the exam. This value will be given, this value will be given. Okay, so basically a power station, in an area a power station, and there are four group of people, there are four section of people, and they use power in different time, they use power in the different time, probably in 2 hours, while other is in other 2 hours, other in other 4 hours, in different time. So at first we need to find out the load curve of that power station, because total four group has been connected, total four group has been connected with the power station. That's why we need to first, at first we need to find out the load curve, because load curve will give us the total data. Okay, from load curve we can move forward the other things, but at first we need to calculate the what is the load curve. But interestingly, the load curve is not given, the table is also not given. Okay, so at first we need to build the table, then will go for the load curve, and then we'll go to the different parameters that should be find out. So a little bit big task, but not so tough. Okay, not so tough, so don't panic, not so tough. We just need to just find out the table, that how it will be the table. And we all know that, sir, that we in the load curve we start from the midnight 12 and end at the 12 also, the total 24 hours, the total 24 hours. Now sir, what will be the dividation, what will be the dividation? At first see that what are the starting point or ending point. You see that in the group A, it gets electricity from 8 a.m. to 6 p.m. 8 a.m. to 6 p.m. Okay, so this is for group A. For group B, it is 6 a.m. to 10 a.m. For group C, it is 6 a.m. to 10 a.m. And finally, for group D, it is 10 a.m. to 6 p.m. and 6 p.m. to 6 a.m. So there are very confusing. Everyone is using an at different time. But for that, we need to just set the section that which time zone we will divide. Okay, how many zones it will be. So for that we need to just act smartly, because we will start at midnight. So in midnight, if we consider at 0, that see how many things are here. You see that 6 a.m, so it will be 6, so 6 will be one zone, 6 a.m is here. Next you can see 8 a.m, so we also need to mention 8 a.m, because if we don't mention 8, we cannot plot group A. For after 8 a.m, you see the 10 a.m, so we also need 10, we also need 10 a.m, so write 10. Next, if you can see, after 10, it is 6 p.m. Okay, we are just taking the, so 6 we cannot write 6 because we have already written 6. It will be international time, 6 plus 12, it will be probably 18. Okay, 18. So 6, so finally we got 6, and finally we end at 24. So how I get this information? I just started from 0 and try to find out which time zone has been mentioned in the equation. That you see that 8 a.m has been mentioned, 6 p.m has been mentioned, 10 a.m has been mentioned, and 6 a.m has been mentioned. So these four mentioned, and we start at 0 and end at 24. So this total 6, this total 6 value I get. Now I will divide using this 6. So the first thing will be 0 to 6, 0 to 6. The second zone will be 6 to 8. The second zone will be 6 to 8. The third zone will be 8 to 10. 8 to 10 will be the third zone. The fourth zone will be 10 to 18. 10 to 18 will be the fourth zone, and the fifth zone will be the 18 to 24. 18 to 24. So that's how you need to divide the whole day into this 5 section using the information from the question. Okay, so let's clear all and go to that. You see that already, according to our findings, this 5 zone has been already divided, now we need to put the load value, the amount of power used by different group. There are four groups. We need to plot the amount of power they have used. So we will go one by one. Already 21 students. Please, if you didn't give your role, please give your role. Okay, so the first one is group A. The group A, you see that 20 kilowatt between 8 a.m. to 6 p.m. between 8 a.m. to 6 p.m. So for group A, we write group A. We search 8 a.m. Where is 8 a.m.? So this is 8 a.m. This is 8 a.m. to 6 p.m. Where is 6 p.m.? 6 p.m. means 12 plus 6. That means 18. So this is 18. So in between these three, okay, I'm sorry, 8 is stops here. So 8 will start from here. Okay, 8 will start from here, because this is the 6 to 8. Yes, this is 8, but 8 is the starting from 8 is here. So from 8 to 6, that means 8 to 16. So in the group A, both the time zone we need to put the 200 kilowatt, because they have used the power from 8 a.m. to 6 p.m. So from 8 to 10 we give 200 kilowatt, and from 10 to 18 we give. Monima raise hands. Okay, let me unmute Monima and ask the question that what is the thing. Okay, Monima, you are unmuted. Monima, you are unmuted. You can ask your question. Any question? Monima, তুমি ওপেন আছো, তোমার কোনো কোশ্চেন আছে কি?
নেটই করতে পারি না।
মনিমা কোনো কোশ্চেন আছে নাকি?
দেখছি মামি।
Okay. So let's get back to the our example one more time. Okay, let's get back to example one more time. So basically, as we're discussing, okay, net problem. He had net problem. No problem. So group A, we just picked 200 kilowatt from 8 to 16. So this is the group A is done. Next is group B, 100 kilowatt between 6 a.m. to 10 a.m. 6 to 10. So where is 6? This is the starting of 6. Where is 10? This is the starting of ending of 10. So 6 to 10. So basically there are two zones. So we will put the value 100 kilowatt, both zone 100 kilowatt, 100 kilowatt, because 6 to 10, this is the time zone of 6 to 10. So both the 100 kilowatt in the this two zone. Okay. So next will be the group C, 50 kilowatt from 6 a.m. to 10 a.m. Similarly, this is 50, this is 50 from 6 to 10. This is 6, this is 10. So we give for group C 50 kilowatt in the both section. Okay. And finally, the group D. The group D is 100 kilowatt between 10 a.m. to 6 p.m. 100 kilowatt between 10 a.m. to 6 p.m. Okay. So Where is 10? This is the starting of 10 a.m. to 6 p.m. This is 6 means 18. 6 plus 12 means 18. So that means we will put the 100 kilowatt here. And after that, 6 p.m. to 6 a.m. So 6 p.m. to 6 a.m. That means from 6 p.m. it will go to 12 night. Then from 12 to 6 to the morning. So that means 18 to 24. That means 6 p.m. to just before the 12 p.m. And after that 0 to 6. That means till 6 in the morning. So we need to put 100 kilowatt in the both two section. I think you understand just the dividing into the time zone and plotting those value into that time zone. Okay, plotting those value into that time zone. So finally we get those everything. Now we will just calculate for the total load in this time zone. So from 0 to 6, if we sum, we'll get 100 kilowatt. From 6 to 8, we get 150 kilowatt. Just summing all. From 8 to 10, we get 350 kilowatt. From 10 to 18, we get 300 kilowatt. And finally, from 18 to 24, that means till midnight, that is 100 kilowatt. These are the values we will use in the load curve drawing. Okay. So we hardly finished this table building. Now we will move to the load curve. So as you see, we need to now build the load curve at first. So from 0 to 6, from 0 to 6, this is from 0 to 6. This is 100 kilowatt. So that's why we have given the 100 kilowatt from 0 to 6. Next, from 6 to 8, this is 150 kilowatt. This is 150 kilowatt. You can see that this is the kilowatt in the y-axis and the time in the x-axis. Okay, from 6 to 8, this is 150 kilowatt. You see that this is 150 kilowatt, and joining with the previous diagram, this is 150 kilowatt. Then it will be 350 kilowatt from 8 to 10. Okay, from 8 to 10, this is 150 kilowatt. So from 8 to 10, this will be, sorry, not 150, this is 350 kilowatt. So from 8 to 10, this is 8, this is 10, this will be 350 kilowatt. Okay, 350 kilowatt, and join with the previous diagram. Sorry for my bad drawing. So this is 8 to 10, we get 350 kilowatt. And finally, from 10 to 16, we get 300 kilowatt. So that means 10 to 16, not 16, 10 to 18. 10 to 18 till 18. This is 18, this is 16, this is in between, this is 18. We get 300 kilowatt. And just connecting with the previous diagram. And finally, 18 to 24, the value is only 100 kilowatt. This 18 to 24 value is 100 kilowatt. So that's how we draw the load curve of this example. Okay, using that information of this line, the total load of that power station, and just plotting, very easy drawing, just the xy axis drawing. Just put that x-axis value, it will be the time value from 0 to 24. That means midnight to midnight, one day, the whole one day, 24-hour. And in the y-axis it will be the load curve. Okay, in the y-axis it will be the amount of load that is used in that different time zone. So from this diagram you can see that, from this diagram, okay, if I clear all my drawing, from this diagram, the peak value, you can see that 350. The peak value, you can see that, that is 350. Okay, that is 350. So this is the maximum demand. As I told that in the load curve, the peak value, the highest value is the maximum demand of that power station. There are 4 groups connected, but the maximum demand of that power station, it is 350 kilowatt, and it happens at 8 to 10. That means in the morning, 8 to 10 it happens. So that's why the maximum demand is given as 350 kilowatt, the maximum demand. Okay, So as you can see, this is the maximum demand of the power station, but if we sum individual maximum demand, you see that for group A the maximum demand is 200 kilowatt. 200 kilowatt. For group B it is 100 kilowatt. For group C it is 50 kilowatt, and for group D it is 100 kilowatt from the information that is given. So if we sum that individual, everyone's maximum demand, if we sum, we get 200, 150, 100, we get 450 kilowatt. That is individual, everyone in different time. But the maximum demand of the power station that is connected of this four group, that is 350 kilowatt. So the diversity factor will be the 450 divided by the 350. The diversity factor, we all know that the sum of individual divided by the maximum demand of that zone. So the 350 and the 450 divided by the 350, it will be the diversity factor. So let's go back to the next slide, then we'll find out that what are the things. The first thing is that diversity factor, we already told that 450 divided by the 350, it will be 1.286. The sum, the 450 is that everyone individual, and the maximum demand of the power station we just find out from the load curve, that is 350. That is 350, we just find out from the load curve. Okay, so next, the units generated per day. Units generated in the previous example we have already showed that how we need to find out that. Just the rectangle, using the rectangle, that means 100 into 6, it will be 100 into 6, the first rectangle. Then will be 150 into 4, sorry, not 4, it will be 2. So 100 into 6, 150 into 2, then will be 350 into 2, then will be this one will be 300 into from 10 to 18, that means 18 minus 10, it is 8 hour. So 300 into 8, and finally 100 into 18 to 24, that means 24 minus 18, it is 6. So that is 100 into 6. So if we just sum everything, okay, we get 4600 kilowatt generated per day. That means total 24 hours, the total generation is 4600 kilowatt hour. That is total generated. This is for 24 hours. But for average load, if we just divide by the 24, okay, if we just divide by the 24, it will be the average per hour 191.7 kilowatt. Okay, this is the average load of that power station in 1 hour. And finally, the load factor, the average load by maximum load. You know that the average load is, we just find out 191.7, and the maximum demand from the graph we can see that 350, the maximum demand. So the average load by maximum demand, if we divide, we get the load factor 54.8%. 54.8%. That's how we will solve this kind of load factor or this kind of load curve example problems. Okay, so I think you understand. I have shown two types, and one thing will be, one more example will be for your homework. Similar, in the similar way, because, and it's very easy. You see that the already division is given. The division is given, the 12 to 8, 8 to 2, 2 to 4, 4 to 10, and 10 to midnight. So division is already given. We don't need to divide anymore. We just need to plot. Okay, we just need to plot. So let's see how this will be your homework. You will see by yourself, but I am still giving you a small idea about that. So you will just from that table, you will just build this load curve from 12 to 8, that is 200 kilowatt. If you see that previous, from 12 to 8, that is only 200. That means we have to sum all the consumers. No load, there is no load, only there is 200, there is no load. That means from 12 to 8 we have to 200. You see that from 12 to 8 there is only 200. From 8 to 2, we have 600, no load, and 200. That means 600 plus 200, 800. So 8 to 2 p.m. will be 800. You see that 8 to 2, that is 800. You can see that is 800 from 8 to 2. Similarly, from 2 to 4, that is 200, 1000, 1200. That means 2400. You see that 2400 in this 2400, that will be from 2 to 4. In the similar way, 800 and finally 400. You see that 800 and 400. So you will build the load curve using that. And the maximum value will be the maximum demand, that is 24 watt. 24 watt is the maximum demand from this load curve. So you will find out the maximum demand. Okay. And the question is the maximum demand of the individual customer maximum demand. If you see from here, the consumer 1, the maximum demand they use 600, 200, 800. So 800 will be the maximum demand for consumer 1. For consumer 2, 200, 1200. So maximum demand will be 1000. And similarly for consumer 3, 1200 will be the maximum demand for the consumer 3. So in this way you will, I have already told that. So you will try this example in your home. Okay. So I have already solved 60%. The rest of the things, the solution is given, but you will solve in by your home, by your own. Okay. So these are the things I need to describe today. The load curve example problem. The next class will be the finishing of this chapter. 2 or 3 more example I will discuss. After that, the subject, the chapter will be closed or the finished. Okay. So we have already seen several examples. So try to practice in your home by your hand. So I'm stopping the share. There are how many students? There are, yeah, so many students, more than 22. So that's it for today. I am unmuting all my students. Is there any questions or feedback, anything you want to ask? Everyone is unmuted. So that was the class for today, my students. Is there any questions you can ask? But I hope that everyone understood. Anyone? Abbas, Aziz, Liton, Mizan, Shafi, Muhammad, Najib, Omar, anyone?
Yes, sir.
Any question, or we can end the class?
Sir, roll 40 net নাই আর
Roll,
আমাদের সিআরও হচ্ছে নেট নাই রোল
please give his role. Yes, Aziz, you tell. Give his role in the chat box. Aziz, tell. Any question? Any question? Everyone is
No,
unmuted.
sir.
Okay.
Yes, sir. No.
Okay. So if there is no question, I will give the video lecture as soon as possible, and also the class lecture I will upload. So try to.
I have a question, sir.
Who?
Aziz.
Abdiaziz.
Yusuf mentioned no option. Sir,
Please, everyone stop one by one. Yes, Aziz, please tell. I'm listening.
sir, I understand the examples, but I have an external question.
Yes, tell.
Sir, our station, how can be synchronized, and how we can synchronize 2 or 3 different alternators with different sizes? We know that when we want to connect an alternator in parallel, we need to adjust the voltage, frequency, and
The phase angle, yes. The phase sequence, yes.
So
3 things.
how we, and in the start of this chapter, you said it is good to use different size alternators with many different. So how can we synchronize? How can we adjust that? That's first question. The second one is how can we know the load curve before we build the power station?
Interesting.
Yes, that is two
Interesting.
questions.
Interesting. Yes. Uh, I will discuss the second one first. You know, before building a power station, the load survey will be,
Oh my
taken. Yeah. Yeah, I got your question. I'm unmuting. I'm muting all for better purpose. I'm muting all. Yeah. You discussed that, sir. Before establish the power station, how can we get the load curve? Yes, that's a very interesting thing. But you know that before load curve or before power station build up, if I want to build a power station at first for a zone, we can all know that how many house will be connected. We can know that because uh, when we give the power, we know that how many houses will be connected, how many industry will be connected. Okay, industry will be connected, how many power house will be connected. So probably you know, some of the students probably you don't know. So when you apply for the electricity, because this should be monitored by an organization in our country, that is PDB, Power Development Board, Bangladesh. So you apply for the electricity. So when you will apply for the electricity, basically you apply for an energy meter. Okay, energy meter, that I want an energy meter that will calculate how much energy I will consume, and that will be according by bill. Okay, so when you will apply for the electricity, there is a part that where you have to mention that how much power you want, how much power is it 100 kilowatt, is it 2000 kilowatt. Okay, so the demand has been asked. So when before building, it's not that it's not that that a power station is built for a zone. Probably at first the power station has been built in a big area, but if I really build a power station for a specific zone, suppose 100 houses are there, that there is no electricity and I want to build, then I will go and I will ask that please give your demand. Okay, so every home they will connect. There are several loads, and every loads, you if you know properly, every loads know has a rated value, rated voltage, rated power rating that I'm talking about, not voltage will be the supply voltage, 220 volt or 420 volt, that will be same. But the power rating, every load capacity, in the fan probably it is 75 kilowatt. Okay, in the light we know that 18 sorry, not kilowatt, it is a watt, 75 to 80 watt. In the light we know that 18 watt. In the fridge, AC, everyone has a power rating. So if we sum all the power rating, okay, so we'll get the total power that we want. So basically all time we used to apply a bit more, suppose, because in future expansion also, we take some extra for future. So if I really build a power station for a specific zone, at that time we don't have load curve at that time. So at that time we will apply for the, okay, the demand curve, the demand. So at that time total, if you get all the demand, you just sum all, and at that specific time you need to sum all and be, uh, take a load factor, because we all know that everyone is taken the demand a little bit higher, and everyone will not use his all loads. Okay, so at that time the power station company needs to, you know uh, take a decision that what will be the load factor we will take. That means we all know that no one will use the power all the time, all the power. So suppose the sum of the power is 500 kilowatt, they know that all the houses will not use the power at the same time, not full power. These are the connected loads. The maximum demand will be definitely the less. So at that time they take a demand factor, suppose 0.8 to 0.9 they take. Okay, the more the demand take the demand factor, suppose they take the demand factor 1, that means their reserve capacity is higher. Okay, they are taking the more reserve capacity. So yeah, That's why they take the value, and according that they build, they make a specific capacity of that power station. And always you know that in the power station, uh, it is not, you know, uh, discrete. Every power station is centrally connected, grid connected. So it's not like that a power station is giving only power to one zone. So it's connected with the grid, so grid is supplying basically the power. Okay, so but still, if we really build a power station for a specific zone and that power station is totally disconnected with everything, at that time you need to get the demand for every home, for every industry, sum it all, then take a factor. That's why we are doing this calculation. Take a factor. Okay, take a factor, run the power, start the power station, and check 1 month. Okay, let's run 1 month and see what is the thing. If it really cannot meet up, at that time you need to make the load shedding. After that you increase your capacity according to that calculations of 1 month or 2 months or 1 year, then make your power station much more, you know, effective. I think you got your answer. And the second thing was, sir, you said that the question was probably, sir, you said that in the variable load there are several units. There are several units. Will be better. One unit is, you know, when one unit works in the full capacity or full rated capacity, it works more efficiently. So because of the load factor, in different times the electricity is not using properly. So that's why we need to divide in a several zone, in the several units. Okay, so sir, how all the units will be connected? How all the units will be connected, or how all the units? We all know that the main thing is that the generation unit is basically connected with the distribution. Okay, the generation unit is basically connected with the distribution. And Aziz, I'm unmuting you. Okay, unmuting you.
Yes.
You can talk me. In this semester, you are studying another course, that is switchgear and protection.
Yes.
In the first chapter, introduction to switchgear, I think your teacher, your respective teacher, have taught you the bus bar.
Yes. Sir.
The bus bar. The bus
Yes.
bar. What is bus bar? Bus bar is the place, or is the a zone where the incoming and the outgoing are connected,
Yes.
isn't it? So if there are
Yes.
four generating station or generating unit, all four generating unit will be connected in the bus bar.
That's part. Yes.
It's not that connected together, will be the bus bar. Then from the bus bar, the feeder will be go to the transmission. Okay, so
Yes.
but the important thing is that the bus bar has a voltage, so you need to make that voltage. You have to at first, you know, that voltage should be same. The voltage cannot be different. Also
Yes.
the frequency, because this is AC. Okay,
Yes.
if your frequency is different, okay, if the frequency is different, it can make the harmonics and it can make the loss. Okay, but you need to make the frequency, you need to make the voltage, so everything, the ratings should be same. And if you connect to the bus bar is nothing, aluminum bar. An aluminum bar
Yes.
basically used for joining. Okay, it's just like a joining, everyone connected here. From there the electricity goes to the transmission area. I think your teacher has understood you properly that what is bus bar,
Yes.
how
I understood.
different types, the
Passport.
single bus bar system, the single bus bar system is sectionized, the duplicate bus bar system, these things you have probably your teacher have described. Okay, so in
Yes.
the bus bar basically all the generating station are connected with their proper ratings, and then the distribution happens.
Thank you, sir.
Okay, I think you got your answer. Thanks for your interesting question and valuable question. I think it will help you. And if
Yes.
you want to know more, definitely you need to study the books also. Okay, you have the proper books, you study the books, and also use internet, use YouTube. There are several things available in the YouTube. So use Google, use internet, use book. So that will help you, because the power station, this course you are studying, besides the switchgear and protection, that subject is very important. The switchgear and protection is very important subject. Okay, so these two subjects you need to understand properly, because these are very application subject. You know, whatever the topics you have studied in the previous semesters, if I remember properly, electrical machines 1, electrical machines 2, Then you have studied power system analysis, you have studied transmission and distribution of electrical power, okay, then switchgear protection, and finally power station. These 6 subjects, everything is correlated, everything is related, you know. The power
Yes.
power is basically related to the machine, because in machine we use we study generator, we study transformer, we study, you know, the motor, we study, you know, different types of transformer, synchronous motor, induction motor, different types of motor. So you know, these things are very important and interconnected. The power
Yes.
factor, we will also study power factor improvement, how the power factors should be improved, because we all know that the
Yes.
induction motor has a very low power factor, very low power factor. If you remember properly, the induction motor has a very low power factor, so you also study the power factor improvement. I'm trying my best. I'm trying. It was very. It will be very easy if I really, you know, solve this mathematics in the board, whiteboard, and line by line. But you know, very tough for me. So that's why I try to. Uh, I try as much as possible for me in the online. So
Thank you, sir.
it's just rest of you in your hands. Try to study in home, okay? Because without study, your teacher cannot drink you the whole thing, okay? Your teacher can just guide you. You need to study, because these are the mathematics you need to solve. It's that's not the in the literature you just read. If there's mathematics, you have to solve by yourself also. So please study. I'm requesting all my students, please study properly. Study properly in this Ramadan time, and probably this semester, the whole semester will be online because of this coronavirus problem. So please try to use this time in home, try to study properly. And that's it from me.
Okay,
so
sir.
so I'm ending this class. I will upload the video lecture as soon as possible. I will upload the class lecture as soon as possible, okay? So study from there. So that's it. Alhamdulillah. Allah Hafiz to all.